We've started looking seriously at Foundation now, and our goal is to begin using Foundation to work with resources, located in local files, on a network, or via the internet. Before we can do so, let's arm ourselves with the knowledge we need. Firstly, working with resources is error-prone. Things can go wrong with local resources, and especially remote network resources. So we must learn about Swift's error handling structures. Then we'll start looking at some essential Foundation types we'll be using frequently when working with resources: URL, URL components, and data. We're at the stage of our exploration of Foundation where we begin to encounter methods that throw errors. So let's get started looking at how we handle these cases. First, we need to know how to recognize functions and methods that emit errors, so let's look at that first. Well, this is very simple. Let's look at a string initializer from Foundation that we'll be using again later. The following method is able to load a string from a given URL. We'll be looking at the URL type later. The keyword we're interested in here is throws. This keyword simply marks that this method can throw errors. Because of the way Swift handles errors, this means that in order to use this method, we must be prepared to handle its errors. So let's give this a look next. Many of you may be familiar with exception-based error handling systems from other languages. This will make Swift's error handling mechanism seem familiar at first. However, there are some important differences. The keywords we will use with Swift errors are do, try, and catch. All three of these keywords are familiar from other exception-based error handling systems. These systems, however, have some important drawbacks, the most important of which is the matter of unhandled exceptions. In many languages, when exceptions are thrown, there is often no requirement to handle them. This often means that thrown exceptions are never caught. Swift attempts to solve this problem with the following compiler-enforced rule. Simply put, if we call a method that can throw errors, we must handle these errors at the same time we call the method. There is no way for a Swift error to be uncaught. For this reason, we will never use the word exception again. Instead, it's perhaps better to think of Swift errors as a special kind of return value. Let's return to our string method from before. In order to initialize a string with the contents of a URL, we need to handle the fact that the initializer may throw errors. Fortunately, we have a few syntax choices in order to handle this elegantly in our code. As usual, we'll start with looking at the longhand method and work down to more shorthand approaches. We'll start with a full do, try, catch structure. Here's the full syntax from Apple's documentation. Similar to exception-based systems, we must wrap our error-throwing code within a do scope with curly braces. Then, every time we call an error-throwing method, we must acknowledge this fact with the try keyword. Finally, we must have one or more catch statements. We can have multiple catch statements in order to use pattern matching to handle multiple different error cases. You'll recall we've already explored this same pattern matching syntax in our coverage of the switch statement. The syntax is the same, in particular the use of where statements to select the appropriate error cases. However, it's not common to have to handle a multitude of fine-grained errors, so we won't look at this syntax in great depth. It's important to know that this is possible, and might sometimes be necessary when dealing with complex Foundation APIs. Let's present a more common, concrete example. Most of the time you'll be interested in the single case where your method call failed. For this, you can use a single catch case. Also note the position of the keyword try. It comes immediately before the method call. If you are not storing a return value from the method, the syntax would be: again, the try is in the same position before the method call. In the catch block, note the statement let error. Here we've assigned the caught error to a constant with the name error. In fact, this is the default name for a single caught error. This means that we can shorten this example by removing the let assignment. This is quite neat, and it's recommended to use the default error name. Let's return to the previous example, assigning the value of the initializer. The constant string is only available here inside the do scope. So what about if we want to work with the value string after the error case has been handled? One possibility could be something like this. Here we declare an optional string variable, enter the do scope, and assign to string if the initializer succeeds. If there's no error, we exit the do scope, but string is still an optional. This is a long structure, and we still have to handle the optional string at the end. This is a common case, and fortunately Swift has an elegant alternative syntax. We've completely removed the do catch block, and simply added the question mark to the end of the try keyword. By now you should understand what this means. Instead of catching any errors from the initializer, we are simply going to swallow the error and convert the return value to an optional, in this case an optional string. This means if the initializer succeeds, we'll have an optional string. If the initializer fails, we'll be left with nil. This also means we can handle both cases using the optional unwrapping syntax we've used many times before. We can use the optional try expression within an if-let optional unwrapping statement. If the method succeeds, we will have our string value to use. If the method fails, we can do something appropriate. Of course, using this structure means we cannot use pattern matching catch statements to handle multiple types of errors. However, you'll find that this structure will be sufficient for most of your error handling needs. Needless to say, we can also use the force unwrap exclamation mark operator. But as ever, this is a dangerous operation. If the method throws an error, your app will crash. Only use the try exclamation mark keyword when you are very sure there's no danger. As ever, the exclamation mark means a dangerous operation. If in any doubt, don't use it.